Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is an update, a very brief update and reaction to a recent press release from the White House related to what we were just discussing in the weekend about C++ being deemed memory unsafe. And I swear I didn't plan this. I had no idea the White House was releasing something like this today. But really what's going on is that they came up with an update. And the update is a press release, and you can read from the name, future software should be memory safe. Okay, so this is now a direct recommendation from the White House, in particular from the White House Office of the National Cyber Director. Basically, I guess this is the entity. I'm not familiar with the intricacies of the American government, but I imagine this is part of the government that deals with the cyber security. And yeah, so there's basically a brief press release. There are a bunch of articles. There's a fact sheet attached to it, and there's also a report that was released called Back to the Building Blocks, a path towards secure and measurable software, just out of the oven. And of course, I didn't have time to read through this whole thing and actually get a grasp on what's going on. And I won't go through all the details, but I highlighted a few passages, and let me know if you are interested in diving deeper into this report and into what it means. Let me just quickly show you a few things that I found interesting. First, in the introduction, there's a paragraph. However, even if every known vulnerability were to be fixed, the presence of undiscovered vulnerabilities across the software ecosystem would still present additional risk. A proactive approach that focuses on eliminating entire classes of vulnerabilities reduces the potential attack surface and results in more reliable code, less downtime, and more predictable systems. Ultimately, this approach enables the United States to foster economic growth, accelerate technical innovation, and protect national security. And you see the mention of national security. As far as I know, this is a big thing. So when this is mentioned, a lot of things, a lot of baggage comes with it. Leaving these risks unmitigated comes with a costly price tag and may allow America's adversaries to attempt to take advantage of the circumstances. So basically what this paragraph is saying is that this is serious and they plan on reducing undiscovered vulnerabilities. And by how do you do that? Well, you reduce the attack surface. That's a great idea in general. And more reliable code and so on by eliminating classes of vulnerabilities. And it seems that one of the first classes of vulnerabilities is memory safety, which the report goes into more detail later on. I also found interesting the second paragraph from the introduction, but kind of the second part of the introduction. Programmers writing lines of code do not do so without consequence. The way they do their work is of critical importance to the national interest. The shift from reaction to strategic preparation highlights the enormous influence the technical community can have on the security of a shared digital ecosystem. This report articulates a dual approach. First, in order to reduce memory safety vulnerabilities at scale, creators of software and hardware can secure building blocks of cyberspace. This report focuses on the programming language as a primary building block. and explores hardware architecture and formal methods as complementary approaches to achieve similar outcomes. Second, in order to establish better cybersecurity quality metrics, the research community can address the hard and complex research problem of software measurability. This report explores how such metrics can shift market forces to improve cybersecurity quality across the ecosystem. So what I read into this is, yeah, there's a structure to this report. I only got to the first part. As I said, this is quite fresh. But the first part is really about programming languages. But then it also discusses hardware architecture, formal methods, and measurability. I'll have to leave that for a later video. If you're interested in this, let me know. But the important thing that I see here, programming writing lines of code do not do so without consequence. I wonder if this might be a signal towards more responsibility being put on programmers regarding to the output, regarding to the results. Maybe I'm reading too much into it. Again, I'm no expert in reading official documents like this, but yeah, it's something that we've been talking about for years, that maybe at some point there will be a need for more responsibility on programmers. And now let's move to the second part, which is called Securing the Building Blocks of Cyberspace. And here the report focuses more or less on, on a few things, but we'll just discuss memory safety. And let me read one passage and then comment, and then the second passage. Memory safety vulnerabilities are a class of vulnerabilities affecting how memory can be accessed, written, allocated, or deallocated in unintended ways. Experts have identified a few programming languages that both lack traits associated with memory safety and also have high proliferation across critical systems, such as C and C++. Okay, so this is naming, it's probably using the report that we were discussing last year and actually naming these two languages as lacking memory safety, therefore being outside of the realm of these recommendations. So honestly, I'm not sure what the C++ committee has done in the last year, but this might be a hit on C++ usage in the future. Because as you saw, the recommendation is for future products, it's not necessarily for current products. But when this happens, these kinds of recommendation typically have shaped the software industry in the past. This is how waterfall was selected as a method for organizing software projects. This is how we got into various methods, like CMMI was one that was requested at some point. So these things have weight, right? These recommendations. And I'm really wondering what will happen to C and, more interesting to me, C++ due to this. Choosing to use memory-safe programming language at the outset as recommended by the Cybersecurity and Infrastructure Security Agency's open source software security roadmap is one example of developing software in a secure by design manner. Okay, so kind of a recommendation, use memory-safe programming languages. And then the interesting, the second paragraph that I found really interesting here is one that details the memory safety vulnerabilities slightly more. So let's go through it because I find it quite interesting. There are two broad categories of memory safety vulnerabilities, spatial and temporal. Spatial memory safety issues result from memory accesses performed outside of the correct bounds established for variables and objects in memory. Temporal memory safety issues arise when memory is accessed outside of time or state, such as accessing object data after the object is freed, or when the memory accesses are unexpectedly interleaved. Many of the major cybersecurity vulnerabilities over the past several decades were facilitated by memory safety vulnerabilities, including the Morris worm of 1988, the Slammer worm denial of service attack in 2003, the Heartbleed vulnerability in 2014, and the BlastPass exploit chain of 2023. For over 35 years, this same class of vulnerability has vexed the digital ecosystem. This sounds a bit, how would you say, annoyed. It's like somebody slapping us, you haven't done your jobs. And look, I kind of agree with them, because these were known issues. It's not like it's the first time we hear about them. So, but very interesting. You have a spatial kind of memory safety issues. So this is typically pointer arithmetics. It's a common example of this. When you have an object but kind of can access outside the memory of the of that object or data structure. And the second one is temporal memory safety issues. So imagine you have, for example, something like a password. Okay, maybe you have a password field inside the user class, let's say, as user object, and you free that object, but the data is still available in memory. And then you can exploit somehow this and read the password from memory, because it hasn't been actually overwritten with something else. So even if the object is no longer there, or the pointer no longer points to that memory area, the data is still in that memory area. Okay, and some of this can be solved with using, I think in .NET there was some kind of secure text or something like that, where you stored things like secrets, password in memory, but then it was guaranteed that memory will be overwritten when freed, and that maybe, I'm just talking from memory now, that it was encrypted in memory, although I'm not so sure about that. But at least you knew that it would go away as quickly as possible, and it won't stay in memory as data, but it would just go away. So that's it. And then maybe another one. Yeah, I highlighted another 2 paragraphs in the next session, which is memory safe programming languages. And the first one, cybersecurity solutions will be informed by engineering best practices, and technology manufacturers building software can tackle this issue by consistently using secure building blocks, specifically adopting memory safe programming languages. There is strong evidence that now is the time to make these changes. So remember, this avoids C and C++. And now is the time to make these changes. Okay. First, technical solutions already exist. There are dozens of memory-safe programming languages that can and should be used. Technology manufacturers are already able to design and build new products in memory-safe programming languages from day one. Second, the transition to memory-safe programming languages has a demonstrably positive effect on cybersecurity. Industry analysis has shown in some cases that despite rigorous code reviews as well as other preventive and detective controls. Up to 70% of security vulnerabilities in memory unsafe languages patched and assigned the CVE designation are due to memory safety issues. When large code bases are migrated to a memory safe language, evidence shows that memory safety vulnerabilities are nearly eliminated. So this sounds to me like a strong recommendation to start new products using memory safe languages. And the last paragraph that I want to talk about, building new products and migrating high-impact legacy code to memory-safe programming languages can significantly reduce the prevalence of memory safety vulnerabilities throughout the digital ecosystem. To be sure, there are no one-size-fits-all solution in cybersecurity, and using a memory-safe programming language cannot eliminate every cybersecurity risk. However, it is a substantial additional step technology manufacturers can take toward the elimination of broad categories of software vulnerabilities. All right. So what do I read into this? Again, without being an expert in policies and government policies, and particularly in US government policy. I don't live there. I don't follow the White House. I'm not that sure how these things work. But what I'm reading is a strong recommendation to use memory safe programming languages, which excludes C and C++, but include things like Rust, Java, or C#, .NET. I think they probably include Python. I'll have to look into this. And a strong recommendation to switch existing legacy code bases to move them to these programming languages. So this would mean refactoring changing large projects from C++ to maybe Rust or something along these lines. Now, of course, this is a recommendation inside US, but this usually spread out in the industry. At least in the past, this is what happened. Because the way this works is that Department of Defense, when they have some projects, they will follow these recommendations and they will ask for something specific, which means large companies will switch to this approach just to be able to get nice contracts with DoD. And then smaller companies would switch so that they can get contracts with larger companies and so on. And this is kind of how this cascades. And it looks serious. And maybe the next question is, what about Linux? Because Linux is mostly written in C. And the thing here is, I expect there will be some, of course, there will be some discussions maybe about Linux, but honestly, I don't think it's so affected. I know part of Linux, of the Linux kernel, I've already started to switch to Rust. And I would expect other projects to take this course. But these recommendations are mostly for new products. So this seems to be where these things stop in terms of recommendation. Now, honestly, this can go in many other ways, but this is my read into it. And if you know more, if you have more information, if you have more ideas about this, yeah, let us know in the comments, and maybe we can all learn something more about this Very interesting topic. But honestly, I think no matter what our allegiances are, whether we like a certain programming language or something else, I believe we need to do something about cybersecurity. Um, on our side, we started learning programs on security for programmers because programmers are kind of isolated in this world. You get a lot of cybersecurity experts, but they speak their own language and they use their own tools. And there are some recommendations for programmers, but really these words are pretty parallel. So we are focusing on teaching programmers more about security and how they should write code and how they should think about code and how they should think about organizing the code so that you get better security by design and through architecture and through uh, testing, automated tests, and through coding practices. So yeah, I believe we need to move in this direction now. Is this the perfect first step? I have no idea. That's very hard to judge, and I guess we'll have to live and see. So what do you think about this? Let us know in the comments. We love comments, and we'll answer, or maybe we'll even make more videos about answering comments on this topic. I think it's a hot topic. It will be very interesting to see what happens and what are the reactions in the industry after this press release. Thank you kindly for the view, and until next time, remember to think, design, and work smart.